In this session, we're going to go over two sections, graphing and 1.2 linear equations and rational equations. Okay, for section 1.1, it's going to be pretty short. We're just going to go over basics of plotting points and then using graphs to determine x and y intercepts. Okay, so let's just practice plotting these points here. We have a coordinate plane. And we're going to plot 2, 5, and let me grab my pen here. 2, 5, and we have the vertical axes, the y-axis, the horizontal axis, which we call the x-axis. And 2, 5, the points are always x value first, y value. And so 2, 5 is going to be 2 at x, 5 on y. So there's 2, 5. Negative 4, 3, go to x equals negative 4, and 3 on the y value. Negative 6 is going to be negative 6 for x, go down to negative 6 for y. 3, negative 1. And then 4, 0. 4, 0 is going to be on the x-axis. Okay, for the x and y intercepts, we have this first, the graph over here on the left. It's a cubic function, and it goes through the x-intercepts at this point, which is negative 2, 0, and at 2, 0. And so while we can write the x-intercepts in coordinates, the homework for my math lab doesn't take coordinates. You just have to write the x values. Just put in negative 2 and 2. For the y-intercept, it's where the graph crosses the y-axis. So in this case, if I look at it carefully, I think it's 0, negative 8. So in my math lab, you're just going to put negative 8. But I may ask you to put the x and y intercepts as a coordinate, so you make sure you know how to do it in point form. Okay, we have another parabola that's looks sideways here. The x-intercepts are 4, 0. In my math lab, though, you just enter in 4. The y-intercept, it doesn't cross the y-intercept, so there are no y-intercepts here. That's actually it for section 1.1. And so, we're actually just going to focus mostly on 1.2 in this session. And so the goals are, we're going to take a look at how we solve linear equations in one variable, also with containing fractions. And then we're going to move on to rational equations, and then recognize the identities, conditionals, and inconsistent equations. Okay, let's first look at how we categorize equations. So most of the equations that you work with, you always get a solution, right? Like x equals 5 or x equals negative 3 and 4. Those are called conditional equations when you do have a solution. And you could have multiple solutions. You could have 1, 2, 3, or even more than that. But you have a finite number of solutions. A second type of equations is when you solve and then your solution is all real numbers. And when that happens, we call that an identity. And then the third type is when you have no solutions. We call that an inconsistent equation. So let's take a look at the three types. We're going to solve linear equations first. And this linear equation is 7x minus 4x minus 6 in parentheses equals 30. When we have parentheses like this and there's a negative in the front, sometimes it helps if you kind of think of it as like a negative 1. And we have to break the parentheses before we do anything else. So we're going to distribute this negative 1 inside this parentheses. The 7x just comes down. The negative 1 multiplied by 4x is negative 4x. Negative 1 times negative 6 is positive 6 because a negative times a negative is positive. And we have equals 30. 7x minus 4x is 3x plus 6. That equals 30. And then we're going to take away the 6 on both sides of the equation, because that helps us cancel the 6 away. Then we have 3x equals 30 minus 6, which is 24. And then the last step, you always want to divide by 3 because it's 3 times x. We read it as 3x, but it's 3 times x. The way we cancel 3 times is divide by 3. And so we get x is equal to 8. If you're taking a test and you have time left over, you can substitute back into the equation to check your work, right? And because for this one, if we were to categorize it, conditional and consistent, what was the other one? It was conditional, inconsistent, and identity. This is a conditional equation because we have a solution. It's a x equals 8. Okay, let's take a look at number 4. Okay, we got, let's see, 7x plus 9 equals 9x plus 1 minus 2x. The x plus 1 is in parentheses. Same idea, when you see parentheses, you want to remove that by distributing the number in front of that parentheses. So the left-hand side stays the same, 7x plus 9. Distributing the 9, we get 9x plus 9 times 1 is 9 minus 2x. Before step, sometimes I see, students trying to move things or cancel things. You always want to combine like terms before you move or cancel things around. So the 9x minus 2x, we can combine that as 7x, and we have the plus 9 at the end. Then you have 7x plus 9. If you notice here, the left-hand side is 7x plus 9. The right-hand side is 7x plus 9. So what that means, we have got the same thing on both sides. So whatever we plug into x, like say 1 or say 0, we're always going to get the same answer. This type of equation is called identity because we can any value for x and always have the same number on both sides. So x, we're going to have all real solutions. And then that is an identity, or the type, we categorize that as an identity. Okay, so moving on from solving linear equations with just variables, now we're going to look at linear equations with fractions. So here is the first example, or number 5, the first example with a fraction. X plus 2 over 2 equals 5 minus x plus 4 over 5. The idea here is whenever you add or subtract fractions here we're subtracting 2 fractions. You want common denominators, right? And then we kind of worked with that in the previous section, P6, with rational expressions. And so let's just rewrite this as x plus 2 over 2 equals, let's make the whole number 5 a fraction by sticking a 1. You can write anything as a fraction by putting a 1 underneath, minus x plus 4 over 5. So if we look at the denominators here, we got 2, we got 1, and 5. The denominators are 2, 1, and 5. And we want to work with the common denominator of 2, 1, 1, 5. So common denominator is a number that divides all these numbers evenly, that has the factor 1, 5. It's going to be 10. If you think about it, 10 divided by 2 is 5. 10 divided by 1 is 10, and 10 divided by 5 is 2. So the idea is I want 10s in the denominators. I want to think about, okay, what will I multiply 2 by to get a 10? Well, we can multiply by 5. And because it's a fraction and we want to keep it equivalent, you must do it to the numerator as well. And so here, the 1, we're going to multiply by 10. And of course, the top by 10. And then here, the 5, the denominator, we're going to multiply by 2. So what we have now is 5. Because we're multiplying the whole fraction or the whole top x plus 2, we're going to put parentheses around the x plus 2. So make sure that's really important that you remember to put the parentheses around the x plus 2 term. And 5 times 2 is 10. We got 10 times 5, which is 50. 10 times 1 is 10. Minus 2 times x plus 4. In parentheses again, and 10. So once we have common denominators, like you see here, we see all 10s. We can cancel those away. So this is only allowed once you have a common denominator, which we have here. So what that means is we got rid of the fractions and only have the linear equation to work with. And that's much better, right? Because with fractions, things can get a little messy. So 5 parentheses x plus 2. Actually, let's just distribute instead of just copying down. With 5 parentheses x plus 2, we can have, we'll have 5x plus 10 equals 50. There is a negative sign. Make sure you can distribute 2 with the x plus 4, which gives us negative 2x minus 8. Combine the 50 minus 8 to 42 minus 2x. And then here on we get 5x plus 10. Just bring this over. So we have 5 plus 10 equals 42 minus 2x. I like moving my terms on the left-hand side. So we're going to add 2x to the left. And we can, at the same time, we can subtract this 10 on the right to cancel this 10 on the left-hand side. So we have 7x equals 32. And finally, we can divide both sides by 7. Canceling the 7 gives us x equals 32 over 7. Yes, sometimes our answers are not like nice whole numbers. We can get a fraction as our answers. We got 32 over 7. Again, if you have time, say if you were taking a test, I would substitute it back in to make sure that it's the same value on both sides. Okay, let's try another one. 6, another linear equation with fractions. I'm going to rewrite it so that it's all fractions here. So 2x over 5 minus x over 1 equals x over 10 minus 21 over 2. Again, I look at the denominator 5, 1, and 2, 10 and 2. It looks like it's going to be the common denominator is going to be 10 again. And so I'm going to choose numbers that will help me get a 10 in the denominator. So in this case, it's 2. Here we're going to do 10. Here, actually, it's already 10, so we don't need to multiply that by anything. So here we're going to multiply that by 5. We get 4x over 10 minus 10x over 10 equals x over 10. What's 21 times 5? 105 over 10. When 10s knock them out, we have common denominators. So now we have 4x minus 10x, which is negative 6x. I think I put an equal sign here. Let me just erase that. And then we got equals x minus 105. Let's subtract this 1x over on the left-hand side. I'll carry that over here. Get negative 7x equals negative 105. And we divide by negative 7. And x is equal to negative 105 divided by negative 7. Give us 15. Okay, so now let's take a look at solving rational equations. These are equations or linear equations with they're equations, but now, and you may think, okay, what's the difference between that and the equations with fractions? These are fractions, but now look at where the x values are. It's in the denominator. What does that mean? Well, if we think about what we did for rational expressions, we also now have to find numbers to exclude the values that make the denominator 0, because we can't, right, have those. We don't want numbers that make the denominator 0. Last time we had called them numbers excluding numbers that we exclude. Sometimes we call them restrictions, or the numbers that make the denominator 0. The same idea here for denominator are 13x, 4, 26x, and 3. If we look at the numbers, I want a number or common denominator that divides 13, 4, 26, and 3 evenly. Let's see here. I know 13 already goes into 26. So I need something really big to fit 26. And I might have to just play around with the numbers a bit here. And let's see if 26 times 26, if we multiply 26 and 4 together, what we would get. I'm going to actually cheat here, not cheat, but use a calculator. Not cheating, just using a calculator, and you are allowed to use a calculator. 26 times 4 is 104, but 104 I don't think divides 3. So actually 104 doesn't work. Let me try 26 times 4 times 3. Okay, 26 times 4 times 3, that's going to be 212, but that looks like a really, really big number. So maybe I can go even smaller than that. And let's try 13 times 4 times 3. Okay, so I'm multiplying 13 times 4 times 3. It's going to give me 156. And I believe 156 divides 26 as well. Okay, it does. 156 divided by 26 is 6. So 156 divides all these numbers evenly. And then because there's an x term, our common denominator is also going to have x. Okay, so here's the way we're going to do this. This is a different way of doing it. So we have 2 and then 13x. If we multiply this by 100, we're going to multiply this by 156x. And then we're going to multiply the 1 over 4 by 156x. And then we're also going to multiply 95 over 26x by 156x. This idea is we multiply by the common, the denominator, we're going to get rid of the fraction. So we're going to also multiply this by 156x. What happens here is you cancel the x, and then 156, take a look at the 156 and divide by 13 and write that number outside. So 156 divided by 13, again, I'm using my calculator, that's going to give me 12. So we get 12, and then the 2, make sure you bring down the 2, plus, right? So here now, 156, if we divide that by 4, let's see what we get. We're going to get 39, and keep that 39x, because we haven't canceled the x this time. And then in parentheses, we have 1. Equals, do 156 now divided by 26, because that's in the denominator. And that gives us 6. So 156 divided by 26 is just 6, with the x also being gone because we've canceled that. Minus now 156 divided by 3 gives us 52. So, and then the x, because we need to keep that x as wasn't canceled away. So look how now the fractions are gone, right? We were able to cancel the fractions by dividing or multiplying the 156x and then dividing that by the denominator. Now we get 24 plus 39x equals, what is 6 times 95? 570 minus 52x. Let's add the 52x over. That helps us cancel that x term on the left. And let's at the same time subtract the 24 over. And that is going to give us 91x is equal to, let's see, 570. I think I wrote a 24, right? 570 minus 24, we get 546. And then we're going to divide that by 91 on both sides. Let me grab a different color. And x is going to be, oh, this is a nice solution, 6. Okay, I think we forgot to write the values that make the denominator 0, actually. Forgot about that. we have to determine what values make this denominator 0. What that means is what will make 13x equal 0, or what will make 26x equal 0. So if we kind of just pull out to find what will make 13x is equal to 0, well, if you divide here by 13, you see that x equals 0 divided by 13 is 0. So if we plug 0 in here, 13 times 0 will give us 0. Means we are going to exclude this number. Same idea for 26x. If you take 26x equals 0, divide by both sides by 26, you get 0. So it's actually just 0 as the value that we need to exclude from the denominator. So these are the values that we exclude, and this is your solution. So don't confuse the two. One is you're finding the value that we need to remove, right? Because that makes the bottom 0. And 6 is the actual solution, because if we substitute 6 back in for x, you'll get the same answer on both sides of the equation. Okay, let's look at number, 8. Okay, it says first write the values that make the denominator 0, then solve the equation. Okay, let's do that first. Let's find the values that make the denominators, or I forget. So how do we find the denominators that make the 0? First, if there's anything that you can possibly factor, do that first. So I see there's a trinomial. We covered factoring in section P5, I believe, one of the sections. And so let's factor that denominator first. That will help us find all the values that make the denominator 0. So there's -15. The leading coefficient is 1, which means that we can just put the last number here. 1 times -15 is -15. We have -2. And then the values that multiply to -15, -2 are 5 and 3. And 5 is negative, because -5 times 3 is -15, and -5 plus 3 is -2. And so we have 1 over x minus 5 minus 4 over x plus 3 equals 8 over, this factors as x minus 5, x plus 3. Okay, so if you look at here, what will make x minus 5 0? Well, x minus 5, we don't want that being 0. And the way that, that the value that makes that 0 is 5. We don't want 5. Same idea for x plus 3. We set that. Say we don't want that being 0. What will make that 0? It's -3. So there's two values that make the denominator 0. It's -3 and +5. So these are the numbers that we exclude. So we exclude these two from the denominator. All right, so now we need to solve the equation. Again, with subtracting fractions, when you work with subtracting fractions like this, what we're going to do is make sure they have a common denominator. You can see that, okay, that the first fraction has x minus 5, but it's missing the x plus 3. So we're going to actually multiply the first fraction by x plus 3. Because the common denominator is x minus 5, x plus 3. We want the denominators to have all the factors. The second fraction, you see that's missing x minus 5. So we're going to multiply the second fraction by x minus 5 and x minus 5. So if we rewrite what we have x plus 3 up top multiplied by the 1. And then the bottom denominator is x plus 3, x minus 5, minus the 4 times the x minus 5. The denominator, which we made the same, is x plus 3, x minus 5. Notice how I'm putting parentheses around the original denominator. So make sure you also do that. Equals x minus 5, x plus 3. Okay, now they have all the same denominator, which what can we do now? We can cancel them and just express it as x plus 3 minus 4 parentheses x minus 5 equals 8. Now look how much simpler that looks. The fractions are gone. We're left just with like a simple linear equation. Okay, now we're going to proceed with solving this linear equation We have x plus 3. This -4, we're going to distribute with x and then -5. So we have -4x plus 20 equals 8. Let's add like terms before we do anything. Actually, we don't have enough space. I'm going to carry that here. So we can combine the x minus 4x and this positive 3 and the plus 20. And so that gives us -3x plus 23 equals 8. Let's subtract the 23 over. And we have -3x equals 31. I think I did something wrong here. Let's see. Oh, I added 23. This is why we have to write with neater handwriting. It says 8 minus 23, not 8 plus 23. So 8 minus 23, let's do that. That's going to give us -15. All right, I'm glad I caught my mistake before I proceeded. So -3 divided by -3, cancel that away. So we have x is equal to -15, -3, which is 5. All right, and then in your homework, you would write, if you wrote, okay, I got 5 as your solution, it's going to say wrong. And the reason why it says it's wrong is because think about what we excluded at the beginning, right? We had said 5 cannot work because of what happens if you substitute 5 back in here. It gives us 5 minus 5, which is 0. And we can't have 0 in the denominator. What that means is our solution that we got is a number that makes the denominator 0. And so x equals 5 does not work. We say, okay, the answer, I know it's kind of weird. We worked so hard to get an answer, but then it doesn't work. We conclude no solution. So this type of equation would be an inconsistent equation because a number that, or the value that we found is a value that, right, we can't plug back in because it'll give us a 0. So sometimes that happens. You watch out for that. Make sure that the answer is not a number that will make the denominator 0. Okay, let's try number 9, solving this linear equation. Actually, it's going to take more space. So let me just make more space with that. It would be good if you can actually pause the video here and try to see, because we've done all these examples or similar examples. Try to see if you can solve this on your own before you check the way that, the next part of the recording, this video here. Okay, so I hope you had a chance to work this one out on your own. So let's try this. We got 3 and then x plus 1 equals 7 plus 3x. It looks much simpler than the previous examples we just looked at, right? And let's distribute the 3. So we have 3x plus 3 equals 7 plus 3x. I want to cancel this 3x term, so we can try that. And we're going to get 3 equals 7. Now that's weird, right? 3 equals 7 looks a little funny because there's no x term. So what does that mean? When is 3 equals 7? Actually, never, right? 3 equals 7 doesn't make sense. How can 3 equals 7? So if you get something like that, an answer here like 3 equals 7, we conclude no solution. What does that mean? There's no value for x that will make this equation equal to each other. It's always going to be not equal. So this is an inconsistent equation. Okay, let's take a look at number 10. This is a rational equation. We're going to first find values that make the denominator 0 and then also solve. Again, try to factor all the denominators if possible. X plus 5 and 7 is already kind of factored. That's the simplest you can get. We can try factoring 7x plus 35. So we see 7 here, we can divide out a 7 from both 7x and 35. That will give us 7x plus 5. So let's rewrite this term as 3 over 7x plus 5 equals 6x plus 5 minus 3 over 7. So let's see what the common denominator is going to be. Okay, I see that they all need 7. So here, this guy has 7, this guy has 7. This guy, the second guy, doesn't have 7. So actually, we're going to multiply this guy by 7. And then it looks like this this has x plus 5, this x plus 5, but this third guy doesn't have x plus 5. So we're going to multiply this by x plus 5. You're kind of multiplying in what's missing in the denominator, because you want all of the denominators to be the same. Okay, so now what do we have? We got 3. We got 7x plus 5. We got 7 times 6 up top, so that's 42. And then 7x plus 5 on the bottom. We got minus 3x plus 5, and then 7x plus 5 on the bottom. Voila, we got denominators, all 7x plus 5. We can knock them out, bring down what's left over. We got 3 equals 42. Let's just distribute the negative. Remember, this is a negative. Distribute the negative 3x. The negative 3 with the 5 gives us negative 15. Add like terms before you move anything around. 3 equals 42 minus 15 is 27 minus 3x. This time, I'm just going to subtract the 27 over. Right, the goal is we're trying to isolate x term. And then what we have is 3 minus 27 is negative 24 equals negative 3x. And then divide both sides by negative 3, canceling that away. So we have 8 is equal to x. So that's a solution. Again, I forgot to find the values that make the denominator 0. Okay, going back here. The values that make the denominator 0, we just have to worry about the x plus 5. What will make x plus 5 equal 0? Or what? And so we don't want it equaling 0. So I'm going to write the not equal to sign. Well, we subtract the 5 away. X can't be negative 5. So this is the value that will make the denominator 0. So we're going to exclude this value. Our solution is 8. So it's all right. 8 is our solution. So we can keep that. And the numbers that we exclude, or the values that make the denominator 0, are negative 5. So you have to answer both in your homework for this week. It's going to ask you for both. What values make the denominator 0? And that you're going to just type in negative 5. And solving the equation, you're going to type in 8. I think we have one more. 11, 4 over x plus 6 minus 1 over x minus 6 equals 5x over x squared minus 36. Okay, again, try to factor all the denominators. X plus 6 is all right, x minus 6. And then what we can factor x squared minus 36. So factor that on the side. This is a difference of perfect squares. How do we know that? Because I know 36 is a perfect square. It's 6, right? Square root of 36 is 6. If you want the x method, you want to do it that way, you can write negative 36 up top. You see there's a, the x term is missing. So you can write 0 and say, okay, what gives you negative 36 but adds a 0? That's going to mean 6 and negative 6. So this factors as x plus 6, x minus 6. So what will make that 0? Well, from x plus 6, I know the numbers to exclude from that is negative 6. And what do we exclude from x minus 6? What will make x minus 6 equal 0? Well, 6 minus 6 is equal to 0. So here's the numbers that will make the denominator 0. So we're going to say, okay, those numbers we can't use. All right, so let's rewrite this in factored forms. 4 over x plus 6 minus 1 over x plus 6 equals 5x. And that is x plus 6, x minus 6. Okay, so what do we have here? We have x plus 6, x plus 6. Oh, that should be x minus 6. Typo. Let me go back. So it doesn't have x plus 6. So the first and third fractions got x plus 6, but this guy doesn't have x plus 6. So we're going to just put the x plus 6 here. We're going to multiply that. And then the second guy and the third guy have x minus 6, but the first guy doesn't. So we're going to make sure it has the x minus 6. Okay, so we have 4. X minus 6 minus x plus 6. Make sure it's in parentheses. Most forgot that. Equals 5x. And they all have common denominators, right? X minus 6, x plus 6, x plus 6, x minus 6. They all have the same denominator. I'll just write they all got the same. So when they have the same, what can we do? We can just knock them out and get 4 times x minus 6, which is 4x minus 24. This negative sign needs to be distributed. We get negative x minus 6 equals 5x. Combine like terms, 4x minus 6 is 3x. Negative 24 minus 6 is negative 20. It's like adding 24 and 6, having that negative sign there. Negative 30 equals 5x. Let's see, from here, what can we do? We can subtract the 3x over, subtract this guy over, to collect all the x terms together. We get negative 30 equals 2x. And then finally, we divide both sides by 2, and then get negative 15 equals x. Or x equals negative 15, same thing. All right, so I hope that helped you understand how we can solve linear and rational expressions. Again, if you have questions, feel free to reach out at any time.